Hey everybody, Mr. Judson here. So let's see, I got a problem here for you guys to try real quick. We're still talking about implicit differentiation. This looks like it would be hard to solve for y, and so I don't want to do a derivative the normal way. I want to do the derivative implicitly. Okay? You guys see if you can find the derivative of that function. Alright, so, if I was doing this, one thing I noticed right away is fraction. Quotient rule, Mr. Judson, really? And implicitly, really? Well, we could do that. It works. But I always like to make things as easy as possible. And so when I look at this, I just think, why not just move that over here and multiply? So I would probably rewrite this as 3x squared y equals, if I bring this over here and multiply, I've got 4 times each of these, so that'd be 4x squared plus 4y squared. And I don't know about you guys, but to me that looks a lot easier than that original problem. All right, so if you want to pause and go back and erase and try to readjust this, you can go ahead and do that. So if I took the derivative now, I would say, okay, I've got a product rule. I got 2 things being multiplied. So I'm going to take the derivative of the first, which would be 6x times y. I just took the derivative of an x term. Plus, leave that the way it is, 3x squared times the derivative of this, which would be just 1. And I took the derivative of y. That's going to equal 8x. And I just took the derivative of an x variable. And then here I get plus 8y, and I just took the derivative of a y variable. So now we need to get all of our x and y stuff on the same side, our dx and dy stuff. So I guess I'll leave the dy on the left. So I'm going to keep this here, I'm going to move this one over. I know I'm going to factor a dy out, so I'm just going to go ahead and do it. This is going to stay here. This moves to the other side and becomes the opposite. And my dx stuff will be on this side. So this will be positive. And then I got to move this to the other side and it'll become the opposite. So a negative 6xy. Okay. Now if anyone feels like I'm doing too much in one shot here, then go ahead and add that extra step in between. There's nothing wrong with that. All right? So now I want dy over dx, so I'll bring this over here and divide. That means I got to take this over to this side and divide, so I get 8x minus 6xy. We're going to divide by this, so 3x squared minus 8y. One thing to be really careful of, because a lot of people get into this habit, which is not a good one. They just go, well, when you do slope, it's the y stuff divided by the x stuff, so I'll just do this over this. And they don't really think about what they're doing. We're multiplying right here. I need to take this set of parentheses, move it to the other side, and do the opposite. I have to divide by this. Okay? Make sure we're thinking our way through instead of developing these shortcuts that really aren't correct. All right? There's my answer. All right, let's try another one. Alright, so yeah, this is really our big push for today, is to use implicit differentiation with trig. And when I look at this, I would say, okay, it's going to be kind of hard to solve for y. If I move this sine of x over here, so I had 1 minus sine of x, divide by 2, I could then do an inverse cosine. But how do you do the derivative of an inverse cosine? More formulas that we're going to have to learn. Yeah. So I don't want to go there yet. I don't want to do that. So I'm going to take the derivative implicitly. So I look at this and say, okay, derivative of a sine of x is a cosine of x times the derivative of the angle, which is 1. And at the moment I take the derivative of the angle, I just took the derivative of an x variable. Okay? When I take the derivative of a cosine, that's going to be a negative sine. So a positive 2 times a negative sine, that'll be a negative 2 sine of 2y. Remember, the angle doesn't change when you do the derivative of the trig function. But then I need to go back and do the derivative of the angle, which is going to be 2, and I just took the derivative of a y variable. And then that equals, the derivative of 1 is 0. So I think this time to get dy by itself, because it's negative, I'm going to move it to the other side of the equal sign. So I get cosine x dx. Over here I get 2 sine of 2y. Actually, I should multiply 2 times 2 and get 4. And then dy. So now I want to know what dy over dx is equal to. So I move the dx over here to divide. That means I got to move this over here and divide. So cosine x over 4 sine of 2y. And that should be in parentheses. There's my answer. Hey, just kind of as a heads up, this happens occasionally in our book, and it may have happened in the last assignment. They ask us to find dx over dy, which isn't really the right way to do a derivative, but there's no reason why you can't, right? So if they would have asked us to find dx over dy, okay, then I'm going to move my dy over here and divide, and I'll move the cosine over here. Really, it's just the reciprocal of this answer, okay? If we get an equation with m's and n's, you know, and they ask us to find dm over dn, it's exactly the same. We just got to pay attention to those variables and make sure we do it right. Or if I've got t's and r's, you know, find dt over dr, we could do that. Especially if you had something like a revenue function and you want to know how that's changing with respect to time. dr over dt, how is the revenue changing with respect to time? A lot of that stuff is going to come up in the next section when we start talking about related rates. Related rates is all about story problems. Yeah. So we're going to have to be aware of that it's not always dy over dx. It could be any variable that we choose. All right? Let me get you guys another one here to try. All right, so this time I've got the sine of pi x, this is my angle right here, plus the cosine of pi y, and that whole thing squared is equal to 2. I want you guys to find the derivative of that. All right, so let's see. I see something inside parentheses raised to an exponent, and so to me that says chain rule. So when I take the derivative of this, I need to bring the 2 down in front. Everything inside stays the same. Sine of pi x plus cosine of pi y. Subtract 1 from the exponent. It's now 1. Times the derivative of the inside. So now I'm going to take the derivative of this, and derivative of the sine is a cosine of pi x times the derivative of the angle, which would be pi, and I just took the derivative of the next variable. Plus, derivative of cosine is a negative sign, so a negative sine of pi y times the derivative of the angle, which is pi, and I just took the derivative of a y variable. And that equals the derivative of 2, which is 0. I kind of like those zeros. All right, so now before I get all the dy stuff on one side and dx stuff on the other side, I need to FOIL this whole thing. Right? I got to do that first. Now, I think, and I can't just take all this stuff and move it to the other side and divide and say 0 divided by anything is 0 because there's variables in there. I got to keep track of that. I could get rid of the 2. I think I will move that to the other side and divide by 2. Okay. I'm also going to factor a pi out of each of these, this pi and this pi. That's a number, and I'm going to move it to the other side and do 0 divided by pi. Okay? I'm going to move the 2 over and divide. If I factor a pi out of each of these, it would go right here. But because we're multiplying, I could write that out in front too, and then move it over just like I did the 2. All right? So we're going to say the 2 is gone, and these pi's are gone. Now I'll go ahead and FOIL. All right, so sine of pi x times each of those, I get sine pi x cosine pi x dx minus sine pi x sine pi y dy. And now I'll take a cosine times each of these. So plus cosine of pi y times a cosine of pi x dx. I can't call that cosine squared because the angles aren't the same, right? They're not like terms. So now I'll multiply these two and I'll get minus cosine of pi y sine of pi x, no, pi y dy, and that's equal to 0. So now I need to get my dy stuff on one side, dx stuff on the other. So when I do that, let's see, I'll leave, the dy terms are negative, so I'm going to move those to the other side. I'll leave these two on this side. So I've got dx times, I should probably write this over here, dx times sine pi x cosine pi x plus cosine pi y cosine pi x. And these two negative terms, they're going to move to the other side, and I'll factor out the dy at the same time, because I don't want to write this again. This will become positive, so I'll have sine of pi x sine pi y. Oops. I don't want this yet. And then when I move this term to the other side, it becomes positive. So plus cosine pi y sine pi y. And so now we want dy over dx. That's equal to this, and I'll move this over and divide. And this will be the last time I write it down. All right, sine pi x cosine pi x plus cosine pi y cosine pi x. I'm moving this stuff over here and dividing. So sine pi x sine pi y plus cosine pi y sine pi y. There it is. And make sure we don't do this. If you're looking at this and going, can't you cancel these? And these right here? No, because this is part of something that's being added or subtracted to something else. So we can't do that. There is no canceling on this one. That's our final answer. All right, so let's try this one. We've got cosine of x plus y equals x plus 1. And what we're trying to do is find the slope of the tangent line at 0, 0. Okay, you don't have to find the equation of the tangent line, just the slope. All right, you guys go ahead and try it. All right, so to find a slope, I need a derivative. So I'm going to take the derivative of this. Derivative of cosine is a negative sine of x plus y times the derivative of the angle, which the derivative of x is 1, and I just took the derivative of x. Derivative of y is 1, and I just took the derivative of y. And that equals derivative of x is 1, and I just took the derivative of x. So, one thing we can do, whenever we're trying to find the slope, I always say take that point and plug it in immediately after you take the derivative. The more time we spend manipulating things, algebraic type stuff, the larger the chance that we make a mistake. Okay? So I just want to get numbers in there immediately. So if I plug in 0, 0, what I really have is a negative sine of 0 times dx plus dy. Now I'm going to go ahead and distribute that, so I get a negative sine of 0 dx minus sine of 0, I don't know why I'm putting those parentheses in, dy equals dx. And I want to go ahead and put that over on this side. Okay, get all my dx stuff together. So I've got a negative sine of 0 I'm looking at this and I'm going, we know what the sine of 0 is. I could change that to a number. But if I do that, what happens is this dx and this dy basically disappear. And how do you write your slope at that point? You no longer have a dy over dx. So I'm just going to leave it for the moment. Okay? So I've got a negative sine of 0 dx, dy. That's this term right here. This is going to go to the other side and become positive, and I'll factor out a dx. So here I get 1. When I move this over, I get plus sine of 0. And now I want dy over dx, so I'll bring this piece over and divide, which means I need to take this piece over here and divide. So I get 1 plus sine 0 over a negative sine of 0, which equals 1 plus 0 over 0. That means our slope is undefined at that point. There must be a vertical tangent line. Not sure exactly how that happens, but I don't really know what that graph looks like either of that original function. But we're getting a vertical tangent, and so the slope is undefined. And so I would just say that. Slope is undefined. Okay? All right. That's what we have for today. Let me get you guys an assignment. All right, so here's our assignment. Finishing up number 10. And we're still on page 149. We're going to do 17, 19, 31, 32, 55, and 57. Kind of a small assignment, but we just had to get that trig part worked into this. And now I think we're ready to move on to related rates, and we'll start that on Monday. So just so that you guys know this, only one video next week. We're not doing anything on Wednesday. That's the beginning of Thanksgiving holiday, and I'm not going to touch that. We'll still turn things in on Tuesday, but no additional work. Okay? All right, that's it. That's all I have. You guys take care. Have a good weekend. Stay safe. See you on Monday.